Hey guys, how's it going? Dan here, co-founder of Prompt Hub, here to talk today a little bit about recommendation systems and how you can use prompt engineering to build something really quickly. And the basis for what we'll be looking at today is a framework called the RecPrompt, which is from a recent research paper that is basically just a prompt engineering framework using multiple LLMs to create news recommendations. But the recommendations could be applied to any type of um, entity, whether that's restaurants, music, books. And so, shout out to the research team that was able to put this together. I thought it was a really insightful paper, and we'll jump right in. So there are a few components to this prompt engineering framework. There is a prompt optimizer, a recommender, and a monitor. The optimizer just optimizes the prompt using LLMs, or in this case, they also tried it manually optimizing. The recommender is the thing that actually makes the recommendations, and the monitor keeps track of all the different recommendations made and evaluates them against certain metrics to see how they do quantitatively. And so here is the general flow. It's a little complicated, but I think we can break it down pretty simply. So here we go with the optimizer, the recommender, and the monitor. The recommender is the one that actually generates the news recommendations. And so that, along with this initial prompt template, goes into the prompt optimizer. So you start with some initial prompt template. Even on the first run, it's just something basic that says, as we can see here, based on the user's news history, blah, blah, blah. So that, plus some of the recommendations, go into the prompt optimizer. The prompt optimizer has a system instruction that is static or frozen. And so that, with the template, plus the examples, are sent to the optimizer along with this meta prompt. So this is the prompt that tells it, hey, based on the observations, enhance the prompt. So all these different things get packaged up and sent to the prompt optimizer. On the other side of the prompt optimizer outputs a prompt, including some of these samples, including any updates that the LLM made, and that becomes what gets sent to the monitor. That gets sent to the user, and everything is tracked through the monitor. The monitor measures and records, as I mentioned, the effectiveness of these newly generated recommendations across a couple of different sets of evaluation metrics, which is what these gray letters are here. It's not super important. We'll go further into the evaluation set a little bit more. And so that refined prompt goes to the recommender. Everything's tracked through the monitor. So it's a little complicated, but it's also not super complicated. And so here's a closer look at that system instruction message that was in the last graphic, but just putting it up a little closer here so you can get a better idea of it. Pretty straightforward, nothing too crazy to write home about. And here's that initial prompt. So the first initial prompt used, that would be get fed into that prompt optimizer. You see we're inputting a lot of variables here. They break it up using headings, using Markdown. They're taking input. There's history. Here's like the candidate news, which is like the potential news to recommend. So there's slots for all these variables to get filled in. We turned this into a template that you can use directly in Prompt Up, so you can grab it, and we'll link it below as well. And so we looked at the optimizer before, and in that case, it was a LLM-based optimization. We were basically grabbing all these things, right? The recommendations, the initial prompt template, that system instruction, and feeding it all into an LLM to get an enhanced prompt on the other side. The researchers also tested manually updating the prompts that were eventually used to make the recommendations. And so they created this situation where they could compare two prompts, the ones being manually created and the ones being optimized by the LLM. And we've written a lot about using LLMs to optimize LLMs. You can read about it all on our blog. Our general position is that we don't think just using an LLM to make your prompt better gets you the best results. We find that it's through iteration, through some human intervention, plus using LLMs for some part of it gets the best results. And so they ran a bunch of experiments testing these different types of methods. They got a news data set from Microsoft. They used GPT 3.5 and 4. And they tested both news recommendations methods, which are just kind of classic recommendation methods, is what we'll call them. So these are random, most pop, and topic pop, and basically randomly selects ones. Most pop gets the most popular based on the total number of aggregate views across the data set. So globally, which ones are the most popular? And topic pop is more related to the specific user based on their browser history. So these are just like not LLM based methods, but still recommendation methods. And then these are also a bunch of deep neural methods were tested. And I'm not going to go too deep into all of them. These are just our well-known deep neural models for making recommendation systems. And so we have the kind of simple recommendations, these deep neural ones, and then we have these LLM-based ones. And within the LLM ones, we have the handcrafted prompt versus the LLM optimized prompt, which is that bottom one, which I know I am covering a little bit there, but that's the LLM one. And so what are we looking at here? So we can see topic pop is the top performer in the first group of methods, which makes sense. If we remember, topic pop focuses on the user's browsing history more so than the global data set. And all the deep neural models outperform the top method up here. They all outperform topic pop. And coming down to the LLM-based ones, there's a lot of interesting things to take away here. Let me just pull up my notes. So yeah, the initial prompt with GPT-4 outperforms most of the neural models. So the initial prompt is just running that prompt that we looked at earlier, not doing any further optimization, not doing anything too crazy. And we can see just using a really strong model like GPT-4 outperforms most of these methods, but not all of them. There's a clear pattern of an LLM generated prompt tends to perform better than a handcrafted prompt, which tends to perform better than just initial static prompt. They're close though. And so I think that's something that's really important to keep in mind. And we'll go a little bit deeper on the percentage differences between these different LLM prompt methods. We see a clear, really big distinction between GPT-4 and 3.5, which is expected. And the only LLM-based recommendation method that beats all of the neural models is this last row here, having the LLM generate the prompt using GPT-4. So I think that's very important to note as well. So not from my favorite part of this paper is kind of digging into the different trade-offs between the different LLM processes. So if we hyper-focus on just GPT 3.5 and 4, we just pick one data set, they're all this pattern is like pretty similar across all of them. But if we look at the initial prompt, which is just, a static prompt, nothing crazy going on. Handcrafted prompt is using the whole framework, but having a human update the prompt based on performance, and then LLM generated is that automated process, which is what we looked at earlier. So we can see from the initial prompt to the handcrafted prompt, there's 1% gain here, 3% gain there. Not crazy, and you could argue that the time it would take to implement the framework is probably maybe not worth it just to get that relatively small gain, but it depends on your use case. And then jumping up from initial prompt all the way to automating the whole process using an LLM generated prompt, 6%, 4%, 5% on average, let's call it. Again, that can be significant, that could be insignificant. It could be setting up the framework is pretty straightforward, but it could be more challenging for you. And so I think it's really important to, when reading these papers, think about your situation, how much engineering power you have, how easy it is to set up these things, and also just understand that the underlying base models are very strong. Having just a good initial prompt can get you pretty far. And again, here's what that initial prompt looks like. Pretty straightforward. You're pulling in just some information. You're not doing anything too crazy. And again, it all comes down to, does that percentage difference make a big difference? And so if you have something at scale performing, then it probably does. If this is just a proof of concept you need to get off the ground, then probably just using the initial prompt in a setup like this is going to be good enough. So again, you could try this in Prompt Up today. We'll have a link to it below as well. And happy prompting. Let me know what you think. If you implement it, feel free to drop us a message, or if you have any questions, drop a comment below. See ya.